All right. So, just a couple of things. Down here below all the course information and your Hawks Link stuff is your homework number 5. I passed out a copy of it last time, but if you want to make an extra copy of it, here's your direct link to it, so it takes you right there. And also, you're allowed to turn this thing in. You don't have to turn it in on Friday in our class. You have to turn it in by 12 o'clock at the review session. If you plan on coming, buys you a few extra moments. You can ask more questions or whatever the case may be. And I do plan on recording the review session of going over the homework set. It's, again, a great representation of what my test is going to look like. The other thing is, when you go to Hawks, a couple of things, just wanted you to notice. I did push back section 6.3 for you guys on the lesson, just to give you guys a little more time to finish this stuff up on those definite integrals, but it is due today. And then we also have coming up, we have section 6.4 and 6.5. We're finishing up 6.4 today and 6.5, but this will all be due this particular weekend. So I will have all this stuff done for you, because when's your test? Next Monday, that's right. So there we go. All right. So, just to remind you guys of all the things we've done so far. The first off you've got to have memorized is your basic formulas for integration, anti-differentiation. So here they are again, and I just took basically the stuff we did in class here and just putting it up here. Remember, the whole goal is we're giving you the derivative and we're asking you what the original function is. So you have to take the antiderivative of the derivative, and you get the original function plus c. Also, some other notations. When I take the integral of the second derivative, that gives me the first derivative plus c. And the classic notation of, because when you integrate, you make the function, quote, bigger with that power rule. Add 1 over add 1 on the exponent makes the exponent bigger. When you integrate a little f of x dx, you get the antiderivative called big F of x plus c. And here are your basic rules right here. When you integrate a constant with respect to x, you get a constant times x plus c. When you integrate x to the n dx, you get x to the n plus 1 over n plus 1 plus c, provided n is not negative 1. The integral when n is negative 1, the integral of x to negative 1 dx, which is the same thing as integral 1 over x dx, is the natural log absolute value of x plus c. The easiest one of all is the famous integral of e to the x dx. It's its own integral, so integral e to the x dx is e to the x plus c. And the classic rules, when you integrate a constant times a function dx, constants go out front, the constant times the integral of the function dx. And when you integrate things that are being added or subtracted, dx, you get to integrate the first guy plus or minus integrate the second guy. Okay? These are basic rules. There's no product rule, there's no chain rule, there's no quotient rule. What you do have is, when you want to integrate this hard stuff, is u substitution. And with traditional u substitution, you let u equal 1 inside parentheses. 2, you let u equal to exponents on e's. 3, you let u equal to the denominator. 4, you let u equal something such that when you take its derivative, up to moving the constant around, the derivative is also in the problem, up to a constant. Now, we've also been talking about definite integrals. This was that section 6.3 stuff we just finished up last time. The integral from a to b, so we put bounds on this guy, of little f of x dx is equal to your antiderivative, big F of x, evaluated from a to b. Fundamental theorem, you plug in top, minus plug in bottom, and you get a scalar number. Now, this again is what we were talking about last time. When you actually integrate the actual function, you are going to get a number, and this number represents the area between the curve back to the x-axis. So this area, this value of an integral gives you a number. And as I mentioned to you guys last time, this is your geometric representation. If you remember, when we talked about derivatives, great time to review for the final exam. When you talk about derivatives, the derivative is the slope of the tangent line. That was your geometric representation. The antiderivative is the area under the curve. So, the last thing I want to talk about is what we're going to be doing today a little bit, and that is this idea of area. Now, when I integrate a function, that part of it may be below the x-axis and part of it's above the x-axis. When you integrate a function that actually is below the x-axis, here's f of x, and from a to b, when you integrate, it gives you the area from that function back to the x-axis. But when the area is located below the x-axis, this is going to be considered negative area. Okay? So it'll be area, it'll be 5, but you have a -5 on it because the area is captured below the x-axis. So there's a problem that when I actually integrate something like this, my function looks like this, and here is 0 to b, whatever it happens to be, and if here's my function f of x, and if I integrate from a to b, or 0 to b, of f of x dx, do you know what answer I'm going to get? 0. The reason why, there's positive area here, but when this area here is captured between the function is negative area, they're the same areas, but one's positive, one negative, they're going to cancel each other out, and you're going to get 0. And we don't want 0 when we're asking the word total area. So when we're asking for total area, and that'll be the key here, total area, you're going to have to, quote, separate the integral. So if I'm going to find the integral, here's, again, some kind of function I made up. Here is a right here, and here is b. So when you start integrating this guy, you're going to get this area and this area. But to figure out the total area, which means you don't want the negative to cancel with the positive, you've got to figure out where they kind of break going from the negative region to the positive region or vice versa. There's going to be this c value here. And what you're going to do is you're going to break it up. You're going to get for total area. You're going to integrate from a to c of f of x dx, and then you're going to integrate from c to b the rest of the way of f of x dx. This is going to give you nice positive area. This one right here is going to be negative area, but I don't want you to cancel negative area. So how do I can take a negative area and make him positive? Well, one, you could either take the absolute value of it, or just put a negative in front of the region that's going to be a negative area. This is why in our notes we said you have to take the difference, because you're actually subtracting these two integrals if you put this one in front. It's this integral minus this integral. The area on top minus the area on the bottom. The area on the bottom is negative, and minus a negative makes it positive. You have to basically change the sign on this thing. To make the positive area, add the positive area so you can get the total area. That's the goal, but you got to separate your integrals and get the two different areas and then make the two areas positive. So, we started this section last time. This is section 6.4. And again, we talked about those concepts and stuff, and we did some problems last time as well. So I wanted to pick it up where we left off, which is right here with B. Again, the directions all say the same thing, which is find the total area. They gave you a function, and they gave you the bounds. This is the function, f of x equals 2x plus 2, and the bounds are from 1 to 2. Anytime you hear the word find the area or total area, you got to sketch it. You got to take a look at what this thing's going to look like. You got to get a graph. Now this one, I don't actually need my handy dandy calculator. I think I can graph this guy. It's f of x, or y equals 2x plus 2. What does the equation 2x plus 2 look like? It's the equation of a y equals mx plus b. Line, okay. It's an equation of a line. What is the y-intercept? This 2. 1 and 2. What is the slope? 2. Great time to review for the final exam on this equation of tangent line. The slope is 2, so I have to rise 2, run 1, so I've got a point here at the y-intercept, which is 2. Rise 2, run 1, and I can go down 2, over 1. And you notice you get a bunch of dots in a line, and just connect your dots. And this is your line. This is the graph of f of x equals 2x plus 2. Now, we want to figure out the area between the curve, total area between 1 and 2. Here's 1. 2 is going to be right about there. And so we're talking about, in terms of ideas, we want to know what this area is in here. Does that make sense? But here's the key to it. Where is this area located at? Above the x-axis. Our function is a positive function. It's above the x-axis. So what we're going to do here is to find area. We're going to integrate the function 2x plus 2 dx from 1 to 2, and I don't have to break up my region at all because the entire region is above the x-axis. Does that make sense? So, take the antiderivative. Well, 2 is a constant. It holds there. What's the integral x, or x to the first power? Add 1 over add 1. What do you get? X squared over 2 plus the integral of 2 with respect to x is 2x. No plus c's on this stuff. You put a bracket and your bounds from 1 to 2. Cleaning up, 2's canceled there, so you're pretty much x squared plus 2x. According to the fundamental theorem of calculus, you plug in top minus plug in bottom. This will give you 2 squared plus 2 times 2 minus plug in bottom. 1 squared plus 2 times 1. And notice the wonderful use of parentheses. Plug in top, parentheses around it, minus plug in bottom. It'll be a real shame for you to do all this work and screw up on some careless error aspect. Okay? This is equal to 2 squared is 4, plus 2 times 2 is 4, minus 1 squared is 1, plus 2 times 1 is 2. 4 plus 4 is 8, minus 1 plus 2 is 3. So the answer is 8 minus 3, which is 5. And notice it's positive because the area is above the x-axis. There's 5 square units of area underneath this function, 2x plus 2 between x equals 1 and x equals 2. Does that make sense? Take a look at the next guy. F of x is equal to 5 divided by 6x minus 6. Well, this one's a little more difficult, so I'm going to graph this one on my calculator here. So I'm going to turn it on. Y equals, and remember, parentheses ran in numerator, parentheses ran in denominator. 5 divided by parentheses 6x minus 6. And I'm going to do a zoom standard, a zoom 6. That's a negative 10 by 10, negative 10 by 10 screen. And I get this graph over here. But look where your region is at. Where's my bounds? Between what two numbers? 3 and 4. 3 and 4 is over here. So I'm going to basically take my little trace and I'm going to go over here somewhere between 3 and 4. And I'm going to zoom in on that little region right there. And there it is right there. So when I graph this thing, you notice that x equals 1 does not exist as a vertical asymptote right there. And what we care about is between 3 and 4. So my graph does this. Yes, there's more graph on the other side, but I really don't care about him. So this is my graph right here. And this is the section between 3 and 4 that I care about. So this is my function. F of x is equal to 5 divided by 6x minus 6. So we're looking for the region. Again, this region is located above the x-axis. So all I got to do is integrate this function, and it's going to give me my area under the curve. I don't have to separate my integrals because there's no negative region on this part. So my area is going to be equal to the integral between 3 and 4 of 5 divided by 6x minus 6 dx. I got a question for you. Do you have this integral memorized? Is this one of the 4 forms of integrals that we have memorized? Nope. Which means to be able to integrate it, I got to use the famous U substitution technique. What are you going to let U equal to? Very good. 6x minus 6, the denominator, because I have a fraction. Then I'm going to take du. Step 1, find u. Step 2, find du. The derivative of 6x minus 6 is 6, and you put a dx on there. Step 1, find u. Step 2, find du. Step 3, move the constant to the other side. Divide by 6 on both sides. That gives me 1/6 du equals dx. Step 4, substitute. And again, I don't worry about the bounds. I'm just going to integrate. This was a division problem, and u is the denominator. You see that 5 on top? It's a constant. What do constants do? They hold over. Leave the 5 there. Constants hold over. This is u, and then you replace the dx. The dx is 1/6 du. Clean it up, and it should turn into a formula that you have memorized. What's 5 times 1/6? That's 5/6, and being a constant goes out front. The integral of 1 over u du. So that would be 5/6. What's the integral of 1 over u du? Natural log absolute value of u. And then the last thing you do is you back substitute. So this would be 5/6 natural log absolute value of 6x minus 6. That is my antiderivative. So all this work is just to get the antiderivative. But once I got that, here's the problem. This will be equal to 5/6 times the natural log of 6x minus 6, evaluated from 3 to 4. And now apply the fundamental theorem of calculus to get your answer. Plug in top minus plug in bottom. So this would be equal to 5/6 times the natural log absolute value of 6 times 4 minus 6, minus 5, 6 times the natural log of 6 times 3 minus 6. That's right here. So this is 5, 6 times the natural log of, let's see here, 6 times 4 is 24. 24 minus 6 is 18. Minus 5, 6 times the natural log of 6 times 3 is 18, minus 6 is 12. And the absolute value of 18 is 18, absolute value of 12 is 12. So here's my answer, but then I'm going to do the famous squiggly equal to, because I believe on the instructions, they said you could also round these to the nearest thousandth, to the nearest thousands. Tenths, hundred, thousandths, that's your third decimal place. Okay? So I'm going to go for that. I'll show you why in a second. So this will be 5, 6 times the natural log of 18 minus 5, 6 times the natural log of 12. And I get the answer 0.337887591, just in case you wanted to double check it. But they did say to the nearest thousandths. Tenths, hundred thousandths, 8 rounds it up. So what is my answer? 0.338. It's a very small amount of area located here. But you know what I'm going to do? The last thing you should do to listen to my words for your next test and your homework set. Show your work is paramount. But after I do any problem that has bounds, my calculator can do this problem for me. And I want to double check it, because we all make careless errors. Everybody makes careless errors. It's just human nature. So use your calculator to double check. And so that'll be, how do I do it? Math number 9. Integral from 3 to 4 of 5 divided by parentheses 6x minus 6, close parentheses, dx. Now, if I hit enter on my calculator, what should pop up? 0.337887591. Let's see. 0.337887591. I know I got the problem right. Does that make sense? Double check yourselves. It's a shame to do all this beautiful math, and if you multiply something wrong or lose a sign, a negative times a positive is clearly positive or something stupid like that, you can make careless errors. Everybody does. And that's what separates A students from C students, literally. Okay? Look at the next one. F of x is equal to 8 plus 8e to the 0.1x between 4 and 5. Well, the first thing I'm going to do is I'm going to graph it. So go over y equals, clear out the old one, try the new one. 8 plus 8e to the 0.1x. Okay? Again, I'm going to do a zoom 6. I always start there, negative 10 by 10, negative 10 by 10 screen. And what do I see? This is going to happen to you. What do you see? Nothing. Does that mean there's no graph there? No. It's just that basically the world is all around here, and all you're doing is looking here, and you see nothing. But so where's the graph located at? Hit the trace button, it'll tell you. It's up there at 16, so this is negative 10 to 10. So I'm going to change, hit the window, I'm going to change the y maximum to go above 16. So I'm thinking 25 or something like that. Make sure you go way above it, and then hit graph. There's my graph, it's up there. All I did was extend it, so it made this thing all the way up to 25. There's my graph right there. So I can graph that thing. It looks like this. And then all we care about is between what two numbers? 4 and 5. So on your x-axis, declare this one to be 4, this one to be 5. And again, we're talking about this area. Calculate the area under the curve. Does that make sense? So, and notice, once again, this area is located above the x-axis. So this area, when I calculate it, will all be positive, which is what I'm expecting for the answer. So the area would be equal to the integral from 4 to 5 of 8 plus 8e to the 0.1x dx. Now, because there's two functions here, I'm going to separate that. That will be the integral from 4 to 5 of 8 dx plus, hold my constant out front, 8 times integral from 4 to 5 of e to the 0.1x dx. Yep, because of the nature of the function, it actually turned into two problems. Well, let's integrate this first guy first. What's the integral of 8 with respect to x? That's your first rule that you memorized. Integral of a constant dx is a constant times x. That would be 8x evaluated from 4 to 5. Fundamental theorem, plug in top. 8 times 5 minus plug in bottom, 8 times 4. 8 times 5 is 40 minus 8 times 4 is 32. What do I get? Does that make sense? That's the first part. Now I got to find the second part. The second part, that's going to be a little more meaty here because this is not a rule I have memorized. Since it's not a rule I have memorized, I got to use U substitution on it. With your traditional U substitution, what are you going to let U equal to? Very good. You let on when I got an E problem, I let U equal to the exponent. So U is going to be equal to 0.1x. Step 1, find U. Step 2, find du. The derivative of 0.1x is going to be 0.1 dx. Derivative of constant times x is just a constant. Step 1, find u. Step 2, find du. Step 3, move the constant on the side. Divide both sides by 0.1. And I'm going to clean it up. So dx is equal to, this is officially 1 divided by 0.1. And 1 divided by 0.1 is 10. So this becomes 10 du. So this problem becomes 8's a constant, it's out front. The integral of e to the u and the dx is 10 du. Put your constants together. 8 times 10 is 80. Integral of e to the u du, that's the easiest integral to remember. What's the integral of e to the u? E to the u, but then you've got a back substitute, so this is 80 e to the 0.1x. So this becomes plus 80 e to the 0.1x evaluated from 4 to 5. This is showing your work. And yes, it's very detailed. According to the fundamental theorem, you plug in top minus plug in bottom on this guy. So this will be plus 80 e to the 0.1 times 5 minus 80 e to the 0.1 times 4. So you get the answer. Don't forget you got 8 here. Plus 80 e to the 0.1 times 5 is e to the 0.5, minus 80 e to the 0.1 times 4 is 0.4, and I'm afraid it don't get much worse than this, but that is actually my answer. So what am I going to do with a crappy looking answer like this? Let's do that squiggly equal to, and let's put that on the calculator then. This will be 8 plus 80 e to the 0.5 minus 80 e to the 0.4. And I get 20.5572584. But again, they did say to the nearest thousand, so tenths, hundreds, thousands. So I stop at the 1, the 7 rounds it up, so that is 0.552. Does that make sense? Did I lose you anywhere? Got a question for you. Did I screw this problem up? Did I make a careless error? I don't think so. But are you 100% sure? No. I'm never 100% sure until I at least do this. Any kind of problem that has bounds, get in the habit of double checking it on your calculator. But please understand what I'm telling you. No work means no credit. And I'm worse than that. If you actually do this problem, set this thing up, and do this on the calculator, at number 9, integral from 4 to 5 of 8 plus 8 e to the 0.1x dx, and I get 20.5517. Yep, I got the right answer. But if you just put that answer right there without any of this work right here, showing me the integration, top minus bottom, the evaluation, it's a 10-point problem. How many points am I going to take off? At least, if not 20. Showing me crap without the work. When it says show your work, this one, especially on the free response part, be neat about it. Question? Yeah, I'm going to put free response on it. I'm going to make it look just like my test. Traditional about final exams is rule of thumb, you got what, 2.5 hours for the final exam? I'm typically going to take one of my tests and basically double the length of it. That's typically what the good size for a test is going to be. So how many questions I have on the last test? Probably around what, 15 plus. I had parts A and B on the free response, so 15. So you're looking at maybe 30 or 40 questions on the final exam. All right, take a look at this next guy. And this next guy is going to be more interesting. Take a look at this. The function is f of x equals x squared minus 2x minus 3. So I'm going to graph that guy. I know it's a quadratic, but I want to know exactly where it is. X squared minus 2x minus 3. And I'm going to do a zoom 6. That's a negative 10 by 10, negative 10 by 10 screen. And there's my parabola. And so I'm going to kind of graph that. This will be this is my function. It hit over here at negative 1. It hits over here at 3. And the graph is a parabola that looks like this. Again, I'm just generally sketching this guy. Does that make sense? But now I look at the bounds. What are my bounds? Between what? 1 and 6. Well, here's 1 right here. And 3, 4, 5, 6 is right here. Extend that thing on, and so there we go. So now if you look at this, I've got two different regions. I've got a region down here and a region up here. Does that make sense? This is one I'm going to have to, quote, separate the integral to two different intervals. So what's my area going to be? And again, the word is the word total area. So the big deal is about the setup. The total area would be equal to the integral between this number right here, which is negative 1 to 3. That's the negative region of your function. X squared minus 2x minus 3 dx. And then the other part plus the integral between 3 and 6 of x squared minus 2x minus 3 dx. Does that make sense? A separated integral. And one other thing. What kind of answer am I going to get when I integrate from 3 to 6 of this function? What kind of answer? The region is located above the x-axis, which means the region is positive. This is a positive answer. What kind of region, what kind of answer am I going to get when I integrate between negative 1 and 3 on this problem? It is located below the x-axis, which means the area is what? Negative. And I don't want it to cancel, so the negative regions, to make a negative positive, I'm going to stick a big old negative in front of it. Does that make sense? And I'm putting that negative right here, and I'll do this at the end to make that answer positive so I can add the two areas together. This is what they're talking about in terms of the, quote, difference. Does that make sense? So now let's just find this guy. To integrate this part here, I'm leaving the negative right here. I'm going to get this answer. I'm going to come over here. The integral of x squared is x cubed over 3 minus the integral of 2x, 2 is a constant, integral of x to the first is x squared over 2, minus the integral of 3 is 3x. I integrated this guy, and I put my bounds between negative 1 and 3. Here the 2's cancel. And then I plug in top minus plug in bottom, and I want to crunch out me an answer. This would be 3 cubed over 3 minus 3 squared minus 3 times 3 minus plug in bottom, negative 1 cubed over 3 minus negative 1 squared minus 3 times negative 1. Plug in top, parentheses around it, minus plug in bottom. Okay? And when I do that, putting it on my calculator here, I get this. It's supposed to be from positive 1, by the way. That's a positive 1. Sorry, from positive 1. I'll put a negative positive 1. Positive 1, positive 1. Okay, so when I go from plug in 3 minus plug in positive 1, we're supposed to integrate from 1 to 6. So 1, 3, I get negative 5.33333 on my calculator. And for you fans that love fractions, negative 5.3333333 is the same thing as negative 16/3. But don't be surprised, it was negative. But that's what's gonna go here, so I'm gonna make it positive, so that'll be minus the negative 16/3, because I'm gonna do negative, the negative region. And then I'm gonna add that to the answer over here. When I integrate from 3 to 6, integrating this guy, this would be x cubed over 3 minus 2x squared over 2 minus 3x. Notice it's the exact same function again, 2 cancel. Evaluated from 3 to 6, you plug in top minus plug in bottom. This would be 6 cubed over 3 minus 6 squared minus 3 times 6 minus plug in bottom, plugging in 3. That would be 3 cubed over 3 minus 3 squared minus 3 times 3. And when I put this on my calculator, I end up getting plug in top minus plug in bottom. It's nothing but a bunch of number crunch. I end up getting 27. So this will be plus, this answer right here is 27. This answer here was a negative 16/3. So I'm going to go put this on my calculator. Negative 16/3 plus 27 gives me an answer of 32.33333. And again, if we do that approximate to the thousandths position, 32.333. That is my answer. Oh, sorry, please. Does that make sense? Plug in top minus plug in bottom, evaluate for the negative region, and negate that. Plug in top minus plug in bottom for the positive region, and just add your two answers together. Does that make sense? One last thing I can do on this problem. And again, showing you some other things, you know I can graph this guy. So if I go to y equals x squared minus 2x minus 3 and do a zoom 6 on this thing, here's my region. Here's my function. There's also another cool integral button located under second calculate. Second calculate, look at number 7. What is that? Integral. But there are two integrals in this problem. So if I do number 7, what was my lower limit for this? Let's go to the negative region first. It was between what two numbers? 1 and 3. So lower limit was 1, the upper limit was 3, and notice it gave me the area under the curve, and it came to be negative 5.33333. So I know I got that part right. And now I'm going to go for the other region between 3 and 6. I do second calculate number 7. The lower limit was 3 to 6, and it gives me the upper limit, which was 27. And then all I have to do now is negate the negative region, make it positive, and add it to 27, and that's where I get my 32.3333. You have to separate the intervals. Does that make sense? Questions? Granted, it's not difficult, but it is tedious on some of these smaller numbers you're plugging in with all these interesting fractions and stuff. All right. Word problems. Yay. Here we go. Listen to the word problems because you no doubt are going to see something very similar on your homework set and test. It says this: it was discovered that after T years of a certain population of wild animals, wild animals will increase at a rate of P of T equals 97 minus T to the 1/3 animals per year. Quote, find the increase in the population during the first 9 years. Okay, after the rate was discovered. Round your answer to the nearest whole number, whole animal. All right, what are they giving me in this problem? They're giving me a derivative, the rate of change, right? The rate of wild animals in a certain area, possums or something or other. I have no idea. All right, now, we want to figure out how many possums have accumulated for the first 9 years. So what am I going to do? I got the rate, and I want the original function about number of animals. What do I got to do to a derivative to get the actual function back again? Integrate it. So this number of animals, okay, will be equal to, it'll be the integral of your derivative, 97 minus 10t to the 1/3 dt. But you got to figure out the bounds. For the first 9 years, that's starting in the beginning, which is 0 to 9. That's what that first 9 years means. It's telling you the bounds from 0 to 9. Does that make sense? Now all you got to do is calculate this thing. So integral of 97 with respect to t would be 97t minus 10 is a constant. Hold over. What's the integral of t to the 1/3? Add 1 over add 1. 1/3 plus 1 is 4/3. That would be t to the 4/3 over 4/3, evaluated from 0 to 9. I would clean this up, flip and multiply. This would give me 97t minus 30 over 4 t to the 4/3, evaluated from 0 to 9. And then fundamental theorem, plug in top minus plug in bottom. This would be 97 times 9 minus 30 over 4 times 9 to the 4/3 power, minus 97 times 0 minus 30 over 4 times 0 to the 4/3 power. Does that make sense? Got a question for you. When you plug in 0 in for t, what's going to happen to both these two terms? They cancel. This becomes 0. So all I got to do is just type in this guy here. 97 times 9 minus parentheses around fractions, 30 divided by 4 times 9 to the 4/3 power. And I end up getting 732.59434419. So when you go back over, you can kind of double check yourself you got this answer here. But then they wanted me to round this to the nearest animal. How many animals is this? 733 wild animals. Does that make sense? Lose you guys anyway. Look at the next one. The marginal revenue from a sale of X candles is given by 4.5 minus 0.16 squared of X dollars per candle. Find the increase in total revenue if the candles sold is increased from 186 to 251. Round your answer to the nearest penny, nearest cent. All right? So they gave me the marginal revenue. Marginal revenue is also known as R prime of X. And they're asking me for the total revenue, the actual revenue back again. So what am I going to do? To take the derivative and get the original function back, I've got to integrate. So your revenue would be equal to the integral of 4.5 minus 0.16 x. I don't do square root. Square root is a half a power dx. But then I just need my bounds. Okay? And I want to know if the numbers increased, sold is increased from 186, so your low number was 186 to 251. Does that make sense? Again, integrating it, showing my work. This will be 4.5x minus 0.16x. Integral x to the 1/2, add 1, that'll be x to the 3/2 over 3/2. Evaluated from 186 to 251. So this will clean up to be 4.5x minus 2 times, 0.16 divided by 3/2 is, make it a fraction, just to make it easy, 8 over 75. I just put that on my calculator. X to the 3/2, evaluated from 186 to 251. So all you got to do now is fundamental theorem. Plug in top number minus plug in bottom number. 4.5 times 251 minus 8/5 times 251 to the 3/2 power, minus plug in bottom. 4.5 times 186 minus 8 over 75 times 186 to the 3/2 power. So when I do this, double check me, I get 138.9 9121532. And they wanted me to round this thing off to the nearest penny. So how much, and this is revenues, don't forget your units. What would that be? Dollars. That's $138.91. Are you confident in terms of your math on this problem? Question.
Did you need to put 8 over 75 or 8 over 5?
I got 8 over 75 when I did the 0.16 divided by 3/2. 0.16. I got that, so, yeah, I got 8 over 75. 8 over, oh. Yeah, I'm sorry. I actually typed it on a calculator. I was just writing it. Thank you. I'm sorry. I missed what you were saying. Yes. But my question is, are you confident on your answer on this thing? Oh, never. So what am I going to do? Math number 9. Integral from 186 to 251 of 4.5 minus 0.16 x to the 1/2 power dx. And I'm feeling better about my answer all the time. All right, the last thing we'll do here next time, I'll finish up this problem, and I got one section, area between two curves. And the big deal about area between two curves you need for the homework, because I only put one question on the homework on this one, is this. To get area between curves, you need this formula. It's the integral from a to b of f of x minus g of x dx. Top function minus bottom function. That's the key on finding the area between two curves. We'll do more of these problems next time. See you guys on Friday. And remember, your homework sets due at the review session. So we're going to be finishing up this last section, very important accounting section. See you guys then.